I'd like to welcome the audience for joining today. We'll be starting here in a few minutes. We got about 2 more minutes before we'll get rolling, and just want to welcome you. Hello, and I want to welcome you to our session today. I'm going to give another 30 seconds to let the people join. I know sometimes the audio can take a little while, so I don't want to start before everybody's connected to the audio. So just give me another 30 seconds and we'll get rolling. All right, let's get started. Hello, everyone, and thank you for joining our presentation today. My name is Todd, and I will be your host. We have an exciting topic of how AI is changing the shopping experience, and we will present a couple of trends in the industry. And don't worry if you're not in e-commerce or retail, many of these scenarios translate across industries. Now, a couple housekeeping notes before we get started. We will be fielding questions at the end of the session. However, feel free to submit them during the course of this webinar so that way we can create a sort of queue. We are really lucky to have two great presenters today. First, we have Sveta Kostinsky, and she is the Director of Sales Engineering at Samasource. She joined Samasource with a deep expertise in scaling businesses with a focus on partnerships, strategy, and technology and sales. Previously at Syngin, she was responsible for expanding business into the autonomous vehicle space. Sveta has a passion for technology and innovation and works closely with Samasource's clients to design great solutions for them. Next, we have Marcelo Benedetti, who is a senior account executive. He's based in the San Francisco area, and he's been with the company for over 3 years. He works primarily with clients in the e-commerce, retail, and biotech verticals, and Marcelo supports Samasource partners by helping them deliver on their training data initiatives and getting their models to production more efficiently. And with that, we'll hand it off to you, Marcelo.
All right, thanks, Todd. And thank you everyone for taking the time to join this webinar. Again, my name is Marcelo Benedetti, a senior account executive at Samasource, and I am joined by my colleague Sveta Kostinsky, our Director of Sales Engineering. For those that don't know, Samasource is the leading training data provider with over a decade of experience supporting a diverse range of industries and machine learning use cases. And as Todd mentioned, our talking point today is how AI is changing the shopping experience. So first, we'll be discussing how AI is currently adopted by retail and e-commerce companies. Next, we'll take a glance at what the future holds for this space. Then we'll discuss the importance of data quality and how partnering with Samasource can help get your models to production more efficiently. And then lastly, we'll be going through a live demo of our platform, SamaHub. So for retail and e-commerce companies, adopting AI is no longer a nice to have. It's a necessary step towards improved customer experience, streamlined operations, and market competitiveness. According to a recent survey, 52 of respondents in this space reported leveraging AI today compared to only 27% in all other industries. And with another recent study showing that over 50% of customers are likely to abandon a retailer after just one bad experience, it's critical that retailers and e-commerce companies use AI to work for and not against them. With over a decade of experience partnering with some of the world's largest retailers and e-commerce companies like Walmart, Kroger, and eBay, SamaSource has the firsthand experience and the in-house technology to support companies at all stages of AI adoption. So now let's take a look at how these technologies are being adopted today and what that means for the end consumer experience. Most, if not all, current AI applications in retail fall into one of these four buckets. Within personalized shopping, we see use cases such as targeted product recommendations based on buyer behavior analytics. Search relevance directly affects how quickly and easily shoppers are finding the products they need. Leveraging NLP to offer enhanced automated customer support is critical, especially in a post-COVID world with more consumers shopping online. And lastly, adopting smart automation into operational logistics such as inventory management, order delivery, and pickup. So we're all shoppers and we've all visited hundreds of different stores, both online and in person. Of course, the truth about shopping is that whenever you visit a store, the majority of the items you see aren't actually the products you want. So no matter which store you're shopping in or which website, you'll likely have to sift through several, if not a lot of irrelevant items before you find what you really need. Through personalizations, brands have the power to turn every shopping interaction into a meaningful, rewarding, and efficient experience. And that's exactly what shopping should be, right? Fast, simple, and personalized. By analyzing consumer data such as web browsing habits, historical shopping data, and social media activity, brands are able to tailor shopping experiences to customers' interests using AI and automation. So what does that really mean for the consumer? Well, first, it means consumers are able to find the actual relevant products and also find ones that are genuinely interesting to them without specifically searching for them through recommendation engines. And in turn, this makes the shopping experience feel more custom tailored, making shoppers much more likely to buy. In e-commerce, relevance has become and remains the underlying criterion for measuring the effectiveness of search. When a customer searches your website for products, the idea is that the results shown to them should be as close to what they're looking for as possible. If shoppers are unable to find what they're looking for efficiently, they will often immediately go to a competitor site. Within the category of search optimization, retailers are using numerous AI applications to improve results, such as search result re-ranking, attribute re-ranking, visual search, voice search, and autocomplete. One example is how Walmart continuously ensures its retail inventory is accurately cataloged. If an item isn't properly cataloged, that may impact reporting of inventory levels and misrepresent availability of items to the end customer, affecting their search results. In this specific scenario, AI technology is used to classify products so Walmart systems can accurately sense availability. And with the help from SamaSource's expert data annotators, Walmart was able to use machine learning to improve its retail item coverage from 91 to 98%. We've also partnered with eBay on a visual search use case wherein we use polygonal segmentation to distinguish items from the background in the images. And we've done this in hundreds of thousands of images over the years. So what this means for the consumer is that when they search for a particular item, they're significantly more likely to find exactly what they're looking for, adding efficiencies to their shopping experience. Today, most companies are choosing AI and automation to complete, augment, and personalize customer service interactions to deliver improved customer experience across various channels. So this entails leveraging natural language processing that can interpret text and voice-based interactions with consumers. So what are the advantages of using these automated solutions, such as chatbots? They can substantially reduce operational costs for retailers, make customer service agents more productive, provide greater visibility into customer needs, expectations, and behaviors, increase customer engagement and personalization, leading to a more satisfied and loyal client base overall. This is especially relevant in these days in a COVID world with consumers shopping online more now than ever before. So how does this directly impact the shopping experience? Well, it means that shoppers will have access to 24/7 customer service, instant responses and answers to questions, improved overall communication, and faster overall issue resolution, which in turn enables customers to do what retailers want them to do, which is spend more time actually shopping. On the operations side, AI implementation is making a huge difference for retail supply chain optimization, as there's a greater need for fast delivery to shops and end customers, and an increasing focus on tight inventory control. Such application helps retailers understand exactly how their supply chain is operating, make improvements throughout, and eliminate waste and overhead. This is especially true when it comes to inventory management. While the conventional form of inventory management was restricted to current stock levels, AI-enabled inventory management is unlocking how companies can maintain stocks based on data related to sales trends over previous years, projected or anticipated changes in product demands, and potential supply-related issues that could impact inventory levels. Also, the introduction of automated robotics in retail inventory management will greatly impact the future of operations. These robots help to cut down on the redundant process of sorting so that workers can take on more creative and collaborative roles. One example is Walmart's introduction of the AlphaBot, an autonomous warehouse robot that helps to enable quicker, more efficient order picking. The system operates inside a 20,000 square foot warehouse style space using autonomous carts to retrieve items ordered for online grocery. After it retrieves these items, AlphaBot delivers the products to a workstation where a Walmart associate checks, bags, and delivers the final order. So the end result for this example and others like it are that customers can expect a more efficient order pickup and delivery process, a reduction in possible order errors, and better customer service with associates being more focused on helping the end consumers. So where do we go from here in this space? Well, US e-commerce sales as a percentage of total retail sales have experienced a major hockey stick growth in 2020, largely due, of course, to the impacts of COVID-19. One study by Forrester shows that there has been the equivalent of 10 years growth in 3 months alone this year in terms of US e-commerce penetration. With more consumers transitioning to shopping online more now than ever, retailers and brands will be focused on leveraging AI to automate e-commerce operations as much as possible. In the near term, this will mean more emphasis on customer service, including more advanced and accurate chatbot capabilities, enhanced personalized shopping functionalities for online consumers, and logistics automation around inventory management and pickup delivery order operations. In the future, we can also expect some exciting innovative breakthroughs to take hold in this space, such as autonomous checkout, for example. Though the widespread adoption will take longer than many anticipated due to various logistical challenges, such as adapting the technology to various store layouts and retrofitting existing stores, we have seen some promising development. One example, of course, being Amazon's autonomous checkout deployment, as we've seen with the Amazon Go stores, and also a very recent announcement that Circle K, a convenience store chain in Arizona, has partnered with Standard Cognition to implement an autonomous checkout pilot at one of their Phoenix locations with plans to expand in the near future. So how can companies rapidly implement all of these exciting AI-driven applications and use cases we've talked about today? Well, through high quality ground truth training data. I'm sure we've all heard the term garbage in, garbage out, which has since become cliche in this industry, but it could be more true when it comes to trying to efficiently build a new model or fine tune an existing one. Of course, if your AI training data set is considered garbage, the resulting algorithm will also be subpar. A false positive in machine learning might produce a poor customer experience for an e-commerce chatbot, erroneous product recommendations, inability to find a desired item, or a multitude of possible shipping errors. So how can you be sure that data you're getting is actually useful? According to McKinsey Global Institute, obtaining high-quality data sets is one of the top limitations for AI adoption. However, it can be a challenge to obtain high-quality data sets at an affordable cost and scale. Regardless of your use case, an effective training data strategy can help you establish a firm baseline for data quality. So start by clearly articulating your end training data goal. This will help determine what data needs to be collected, as well as the level of data quality required to meet that goal. Dataversity shares 9 dimensions of data quality to keep in mind when doing so, in order to reduce the risk and cost associated with poor quality data. This includes data accuracy, completeness, consistency, integrity, reasonability, timeliness, uniqueness, validity, and accessibility. High quality data is imperative to the success of your algorithm, and having a dedicated team can provide the added benefit of industry and use case expertise. Over the last decade, SamaSource has submitted over 500 million labeling tasks with tens of billions of labels to train our partners' machine learning models. With our vertically integrated workforce, robust annotation platform, which you'll see soon, and consultative approach to project management, we have the knowledge base and firsthand experience to help our partners efficiently train their algorithms while ensuring they get the most value out of their data sets. So now I'm going to pass the baton over to my colleague Sveta, who will do a deeper dive into the quality process and also present a demo of our platform, SamaHub.
Thank you, Marcelo. So how do we ensure this high level of quality that Marcelo was talking about? In SamaSource, we believe in quality transparency. So we start every project by sitting down with our clients and defining the quality rubric. And this is our way to quantify quality and design it in such way that we will be able to define what are the different penalties for different errors. We would then use this quality rubric as a gold standard for the project. And we would train our agents to meet the quality requirements as defined in the quality rubric. We would use the sampling methodologies within SamaSource, the SamaHub sampling portal, in order to ensure that we are aligned with the different quality scores that are defined in this rubric. And we also can implement a few of the additional automated techniques like automated sampling for goal tasks and AutoQA to meet the standards as designed in this quality rubric. Let's start by talking a little bit more about AutoQA. AutoQA is a technical capability that developed that allows you to check for fixed sets of rules and ensure that there's no errors when it comes to configuration of the specific rules in the metadata definition within the shape, across all shapes, or independencies between the shapes. And it comes right here as a process step in between the data annotator, data trainer submitting the tasks, and the manual QA step. The task will go through AutoQA step and will be rejected back to the data trainer in case of there's any logical errors that we were able to catch with AutoQA. So in short, AutoQA improves overall time per task and the quality of the task, as well as reducing the time of the task creation to delivery. Here is an example of AutoQA. So in this specific use case, we designed an annotation sample where we had to track motion for motion tracking of algorithm. And the motion tracking had to follow the task requirements was to follow 15 key points. Each one of the shapes design had to have a separate head for bounding box, separate head for torso, for full body, and had to have a unique group ID for every person and have a specific gender attributes. Here are some of the examples that we were able to catch with AutoQA. For example, in this first group of person number 1, we were able to determine we were missing a head bounding box. The grouping was done incorrect versus where there is an inconsistent attribute, which was female for one part of the person and was a male for another part of the person. Some of the other errors is that this specific bounding box, again, was incorrectly grouped. Some of the key points for this shape were missing. Now let's jump into a demo and talk about additional processes and quality capabilities we have within our platform. So currently I'm inside the SAMA Hub sampling portal. As I mentioned, we believe in full transparency with when it comes to quality, sharing quality with our clients. And the sampling portal is the part of SAMA Hub, which we use and our clients would use to provide us feedback on the quality of the annotated samples. Here you can see in annotated video samples, when we track the journey of a couple going through cash or release checkout use case in the store, picking up few items, putting them in a cart and moving on to the cash or release checkout. You can see that the video sample is kind of spread throughout the bar here at the bottom, the slide bar, and it can move across the frames and tracking the motion of these different shapes. As a quality manager, I will be able to score the specific task based on the quality rubric requirements that I defined ahead of time, provided, for example, a score of 90%, and then I can approve or reject that specific task. I can also add additional comments. For example, when rejecting a task, I can say that, indicate that this specific bounding box is not meeting the 2 pixel threshold requirement that was defined ahead of time. All these are some of the quality controls that we have, and our clients are very appreciative of being able to both review and have visual representation of the task inside the SAMA Hub, as well as provide us detailed comments on to how they would like the annotations to be changed or adjusted. And this provides this fast feedback loop to our agents and improving on the high quality pretty quick throughout the ramp process. Let me double click on this person one bounding box and track that shopper in his shopping experience. You can see as I'm tracking the shopper, I will have on my slide bar this dark lines indicating keyframes. The keyframes are indicative of the frames that the agent had to actually touch up in the annotation. And in between these frames, our algorithm will complete the annotation using linear interpolation algorithms. That means that I don't need to, as an annotator, I don't need to touch up every frame. And this will be a huge time saving for me when annotating video tasks. Another interesting capability that we have is if I double click on this object, I can see that I have both static as well as dynamic labels. This allows me to track pretty complex behaviors of the shopper beyond defining a static label, which can be designed as a radio button or as a drop-down menu from a variety of different label types. I have the concept of defining a dynamic label, which is capturing the dynamic state of an object. In this case, it will be the dynamic state of occlusion. It can be a state, if I'm thinking about other use cases, of a parked or non-parked car, different lighting conditions, or really any change in state that I would like to track. This capability allows me to track pretty complex scenarios and pretty complex object behaviors throughout the video and the different frames. You can see that as I'm moving along, that my occlusion levels are changing from 30 to 60 to 100 and back to 30% for this specific object. Some other things that are important to mention is that obviously I have a coupling set of the spaces are completely customizable for each project, and I can design my project to reflect the requirements for this project, both in terms of the label list to reflect the requirements of the taxonomy for shape labels, as well as for video level labels. like I have here at the bottom, indicating what is the department this video is taking place in. We work with a lot of different types of data, video data, image data, as well as LiDAR data for some of our autonomous vehicle clients. And just to show you another example, another annotated sample for search relevance use case for our e-commerce clients. This is an example where we have annotated this image inside the camera. We're using our raster semantic segmentation. I can zoom in and you can see this is a very high quality image. I can really zoom in to inspect the quality of the annotation on a pixel level. And as a QA manager, I can view the accuracy of the annotation, hovering over the different labels. I can look at the quality of the annotation as it was done, switching to see only the raster mask as it presented on the screen. Beyond the two annotation types that I mentioned, we have a variety of different annotation techniques that we use: instance segmentation, semantic segmentation, panoptic segmentation. It really depends on the project and the requirements of the project. And we obviously would recommend different annotation approaches to different projects based on the algorithm needs, and be happy to work with our clients to design the project in a way that would be most suitable. This is a high-level overview of our Summer Hub and the quality process, and we look forward talking with you and answering any of your questions in future webinars.
Well, thanks team for that great presentation. So at this point, what we would like to do is field some questions. And how you do that is you use the Q&A button that's on the lower right-hand side, and we'll be able to answer those for you. So let's jump right in with the questions that came in during the webinar. So the first one is, you reference 4 areas of that are hot in e-commerce: personalized shopping, operations, search relevance, and customer support. Is SamaSource specifically seeing engagements with those type of applications?
Yeah, I can take that one. The answer to that is yes. We are currently working with partners on active workflows in each of those categories. Of course, those categories are somewhat broad and can encapsulate a wide range of different types of use cases or individual tasks that we see. But yes, we do have experience with each of those kind of overarching categories.
Thanks, Marcelo. The next one is, based on your experience, when companies adopt these sort of new waves of things, how long does it take to actually see fruition or return on investment or improvements in processes based on your experience?
Yeah, that's an excellent question, and one wherein I'd say the answer varies quite a bit. Of course, it really depends on at what stage of AI adoption the client first comes in to the experience working with SamaSource at. We've seen clients come in at varying stages. Some already have a model that's full production ready and directly affects either their search relevance or a product recommendation engine. Others are still very much in an exploratory R&D type phase. So it really does depend. I would say on average, what I've seen is probably if they're starting from, let's say, the very early adoption stage, potentially around, it of course also depends on how quickly they can develop their algorithms. But I would say around 8 to 12 months to really see end customer experience gains and potential ROI. So I'd say around 8 to 12 months.
All right, thanks. And the next one is, when utilizing, the question is do we, meaning the customers, have to use I think you call it the hub, or is it one of those things where it's a service and you help with the project management aspect of it? Like, what does that engagement sort of look like?
Yeah, great question. So we really offer end-to-end training data support. So that includes the project management aspect, the consultative approach, working with you to develop a training and quality strategy and rubric. For most projects, we do use our in-house platform, SamaHub. However, there are cases wherein maybe a client has developed a tool very specifically for that task that they need support with. So there are instances where we do use external tooling as well.
Great. Well, I think that's it for now. I don't see any more questions that came in, and great job, team. And for those of you who participated, we enjoyed your company, and thanks for joining, and hopefully you'll be able to attend our next webinar. And with that, we'll wrap it up.
Thanks, everyone.
Thank you, everyone.